Hello, this is the third lectures of electrostatics and the topic is Coulomb's law of electrostatic interaction. This law is applicable for point charges only. Point charges only. Now say this is one point charge and this is one point charge. The magnitude of this charge is Q1 and magnitude of this charge is Q2. Distance of separation between them is R. That means two point charges Q1 and Q2 are separated by distance R. Therefore, the force of interaction between the point charges, is directly proportional to the product of magnitude of their charges, and inversely proportional to the square of the distance between them. The force of interaction between two point charges Q1 and Q2 separated by certain distance in a medium is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. So therefore F proportional to Q1, Q2, F proportional to 1 by R square. This is also called the inverse square law. That means Coulomb's law obey the inverse square law. Coulomb's law obey the inverse square law. That means force of interaction between the point charges is inversely proportional to the square of the distance between them. So combining these two, we will get F proportional to Q1, Q2 by R square. So there the constant comes small k, it is called proportionality constant. The small constant k is comes. So therefore, F is equal to K Q1 Q2 by R square. K is called proportionality constant. In SI system, this constant K is taken as 1 by 4 pi epsilon. In SI system, this proportionality constant, the value of proportionality constant is taken as 1 by 4 pi epsilon. Epsilon is called absolute permittivity of the medium between the point charges. That means if the medium differ from each other, if we change the medium between two point charges, the force of interaction between same two point charges will be different. Is it clear? That means if we change the medium, the value of epsilon changes. Therefore, force of interaction between them also changes. That means if we put the K as 1 by 4 pi epsilon in SI system, then force of interaction between them is 1 by 4 pi epsilon Q1 Q2 by R square. This is equation 1. This epsilon is called absolute permittivity of the medium. That means if we change the medium between the point charges, then force of interaction between them also changes. Now, if the forces are like charges, if the charges are like charges, then force of interaction between them will be repulsive in nature. If the charges are unlike charges, then force of interaction between them are attractive in nature. That means force is repulsive for like charges and force is attractive for unlike charges. Is it okay? Now, if we replace the medium between the point charge as air medium or vacuum, if we take the medium between the point charge is vacuum or air, then proportionality constant has a value 1 by 4 pi epsilon 0. That means if the medium between the point charge is air or vacuum, the proportionality constant has a different value 1 by 4 pi epsilon 0. This epsilon 0 is called permittivity of free space. It has a value 8.854 into 10 to the power minus 12 coulomb square by Newton meter square. Because for air and vacuum, this epsilon 0 has a constant value 8.854 into 10 to the power minus 12 coulomb square by Newton meter square. So here Here 4 is a constant, pi is constant, 3.14, epsilon 0 is constant, 8.854 into 10 to the power minus 12. That means their product should also have a constant value. So what is the product of 1 by 4 pi epsilon 0? It is 9 into 10 to the power 9 Newton meter square by Coulomb square. This means these 4 constant, pi constant, epsilon 0 constant. So therefore product also has a constant value. And the value of 1 by 4 pi epsilon 0 is 9 into 10 to the power 9 Newton meter square per Coulomb square. That means if the medium between the point charge is air or vacuum, Coulomb's law is written like this: F air is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square, equation 2. Or we may equation 2. Now, if we divide equation 2 by equation 1, equation 2 1 by 4 pi epsilon 0 Q1 Q2 by R square. What is equation 1? Can you remember equation 1? Equation 1 is F is 1 by 4 pi epsilon Q1 Q2 by R square. So if I divide equation 2 by equation 1, F air by F, I will get this. This is equation 1, this is equation 2, this is equation 1. Q1 Q2 by R square, Q1 Q2 by R square get cancelled. 4 pi get cancelled. So we get epsilon by epsilon 0. So this epsilon by epsilon 0 is another constant. It is called K, or sometimes written as epsilon R. K or epsilon R. This K is called relative permittivity of the medium or dielectric constant of the medium. It is K or epsilon R. That means that epsilon can be written as product of epsilon 0 into K or epsilon 0 into epsilon R. Epsilon, absolute permittivity of the medium, can be written as a product of permittivity of free space and dielectric constant of the medium. Actually, the value of dielectric constant of medium is 1. Value of dielectric constant of medium is 1. Therefore, in SI system, epsilon 0 is written instead of epsilon in SI system. Instead of epsilon, we have to write epsilon 0 because the value of dielectric constant of air is equal to 1. That means epsilon by epsilon 0 is K. It is called dielectric constant of the medium. So therefore, A is nothing but the ratio of force between two point charges separated by certain distance in air medium to the force between same two point charges separated by same distance in the medium. Being a ratio, it has no united dimension. So what is dielectric constant or relative permittivity of the medium? The symbol is K or epsilon R. K means, that means epsilon means epsilon 0 K, or epsilon is epsilon 0 epsilon R. For air medium, this epsilon R or K has a value 1, equal to 1. So therefore, dielectric constant of a medium is the ratio between force between two point charges, ratio of the force between two point charges separated by certain distance in air medium to the force between same two point charges separated by same distance in that medium. Being a ratio, it has no united dimension. Okay?